Today we're going to talk about matrices. The introduction to matrices, how we add, subtract matrices, how we can use scalar multiplication with matrices. So to begin with, a matrix, okay, is a rectangular arrangement of numbers in rows and columns. These can be in any dimensions, 2 by 3, 5 by 7, 15 by 27. Anything you can think of, whole numbers. Right? And when we express them, they're in rows by columns. So we always want to think about the dimensions of a matrix. Because if they're not the same dimension, we cannot add, subtract them. And once we get to after scalar multiplication, more complex things, they have to be in different orders as well when we talk about multiplying them, things like that. But we're going to stick with the basics this lesson. So we're looking at like this matrix. You see it's kind of like big brackets surrounded by numbers. Each of these numbers is an element. So in this matrix there are 6 elements. That's the other vocabulary word. Element is each piece of data inside a matrix. So if we look at this, we have how many rows? We have 2 rows, and we have 3 columns. 2 rows, 3 columns. So this is a 2 by 3 matrix. And again, I just threw up here some examples that you can see. Second matrix. We have 3 rows by 1 column. Therefore, this would be a 3 by 1 dimension matrix. And again, we can go a little bit bigger. We have, again, 9 pieces of information. This would be a 3 by 3. 3 rows, 3 columns. So I mentioned about adding matrices up. In order to be able to add a matrix, 2 matrices or 3 matrices or 4 matrices or anything like that, they need to be in the same arrangement, the same dimensions, the same amount of elements. If you have a 3 by 4 and a 4 by 3, those are not the same. We cannot add those together. So our first problem that you might see in our notes is this. We want to add these up. When we're adding these up, as you can see, 2 rows by 3, 2 rows by 3 columns. We can add these up. When we do, we need to be able to add up the similar elements. So if we look, first row, first column, we can add with the first row, first column. We can, because this is an addition, we can add these up. This will result in the same size matrix, a 2 by 3 in these boxes, just the way it looks. So we go 1 plus 4 is 5. Okay, now look at this one. This number and this number. 2 plus negative 5 is negative 3. 3 plus a negative 1 is 2. 4 plus negative 3 is 1. Negative 5 plus 2 is negative 3 again. And negative 2 plus 1 is negative 1. So we can combine matrices. And this is what it's saying. Like these 2 pieces of data are similar. These 2 pieces of data are similar. Kind of in the same rows and same columns. If we look at number 2, again, this was a 3 by 1. 25, 5, 9. And this time I think we're subtracting. Remember, the subtraction goes to every element. So again, we go 25 minus a negative 5, and we end up with 30. 5 minus 5 is 0, and 9 minus 2 is 7. And here's our answer here. And I made up another matrix. I want you to try this one. Here we have 1, negative 4, 5, negative 2, 6, negative 3, minus 0, negative 1, 2, and 5, negative 4, 1. Take the time, try to solve this. Your hint, again, this is a 2 by 3 matrix. It is going to result in a 2 by 3 here. So you can solve that one and submit it with your notes. Now the last part of this is what we call scalar multiplication. Okay? We all know how to multiply. We're just throwing in the word scalar. What scalar means is that everything associated with that matrix gets multiplied by that number. So we started with this problem. We had a negative 2 out front, multiplying this. And here I threw a fraction in here. All right? We can't have fractions, we can't have decimals as an element in our matrix. So we need to multiply this negative 2 to every single element here. So when we multiply it out, negative 2 times 5 is negative 10. Negative 2 times negative 4 is positive 8. Negative 2 times 1 half, negative 1. Negative 2 times 10 is negative 20. Again, we kept the same size matrix, a 2 by 2 down to a 2 by 2. And here's number 5. Here we're multiplying by 6. So we start with a 3 by 2 matrix. We need to end with a 3 by 2 matrix. 6 times 4 is 24. 6 times negative 1 is negative 6. 6 times 0 is 0. 6 times negative 2 is negative 12. 6 times a third is 2. And 6 times negative 4 is negative 24. Again, start with a 3 by 2. We finish with a 3 by 2. When we're multiplying with scalar multiplication. Okay. Hope this helps, and I'll see you next time.